Okay, so now I'm going to take you through the reciprocals of the trigonometric ratios. Very much important that you take note of the word reciprocals. Trust me when I say this is not complicated. It's going to be an interesting part of trigonometry that we are going to look at. So let me just make you aware that since the beginning of this topic, we've been talking more about cos, sine, and tan. And we do know very well that the ratio for cos is adjacent over hypotenuse, sine opposite over hypotenuse, for tan is opposite over adjacent, so katua. Yes, so now we are going to be talking about the reciprocals of trigonometric ratios. So since cos is adjacent over hypotenuse, and then for this one is opposite over hypotenuse, for this one is opposite over adjacent. So the reciprocal of this, it's simply you taking h to the top and then a to the bottom. That's it. For this one, it means you take h to the top, o to the bottom. That's it. Then for this one, it would be a over o. That's what a reciprocal is. So that means if you have 1 over 2, the reciprocal of 1 over 2 is 2 over 1. The reciprocal of negative 4 over 3, this would therefore be negative 3 over 4. That's all that we are going to be talking about regarding the reciprocals. So if we have cos, then we will need to find the name for the reciprocal of cos. We will need to find a name for the reciprocal of sine, same for tan. Maybe straight away, let me get into those names. So we have, let's say, cosec, we have sec, and we have cot. It is 3 of them because it is the reciprocals of the 3 trigonometric ratios. Maybe let me give you a moment to guess, to say, for cosec, sec, and cot, which one do you think is the reciprocal of those trigonometric ratios? For example, cosec, is it the reciprocal for tan or for cos or for sine? Same for sec and cot. One thing for sure, it is easy to guess, but you may be wrong when you guess. So I'm going to show you the most easiest way to cram this thing so that you will never forget which one is the reciprocal of what. So you look at letter number 3 from these given words. So this is 1, 2, 3. What is letter number 3? Is S. So this S stands for sine. So that means cosec, it is the reciprocal of sine. Letter number 3, 1, 2, 3. This letter is C. C for what? For cos. So that means sec is the reciprocal of cos. Letter number 3, 1, 2, 3. See there, letter number 3 stands for T. T for tan, which means cot is the reciprocal of tan. So maybe just so that it makes even more sense, let me start it this way to say what we know is that sine of an angle, we know it as opposite over hypotenuse. So what I'm saying is cosec, since it is the reciprocal of sine, it means cosec, you just swap h to the top, o to the bottom. That's it. So you are just swapping, and you just need to know which one is the reciprocal of which. So when it comes to cos, we do know very well that cos of whatever angle it is the same as adjacent over a hypotenuse, which means when it comes to the reciprocal, it will just be that h over a. That's it. It doesn't matter whether it is x over r or y over r or y over x. What you know is that when it comes to the reciprocals, you just swap. We know that for tan of an angle, the ratio for tan is opposite over adjacent. So that means when it comes to cot of an angle, it will therefore be equals to adjacent over opposite. So the teacher in your school can explain to you differently and say a sec or cosec, it doesn't matter. Sec of an angle, they can say it is the same as 1 over cos of an angle. It is still the same thing. I will show you just now. When it comes to, let's say, cosec of an angle, they can still say it is 1 over sine of an angle. Then even when it comes to cot of an angle, they can still say it is the same as 1 over tan. Let me prove it to you so that you will understand when I say it's the same thing. Remember that here is the same as you having 1 divided by cos. So it's the same thing as 1 divided by cos, which means it is the same as 1 divided. What is cos? We just said cos, it is adjacent over hypotenuse. From primary, we do know very well that when you're given this is the same as 1 multiplying then h over a. What will this end up being? 1 multiplies the h, then you end up having h over a. You see, it goes back to what I was explaining there to say it is actually h over a. Same thing here, it is same as 1 divided by, what is sine? We just said sine is opposite over hypotenuse, and this is the same as 1 multiplying, then you just swap, and then you have 1 multiplying the 1h, and then it becomes h over o. Same as this one for tan, is the same as 1 and then opposite over adjacent, which is the same as 1 multiplying, then you swap. Then you have this, which ends up being 1 multiplying the 1a there, it becomes a over o. So it just depends on how you present it, but at the end of the day, it will just remain as the same thing. Very much important there. So for me, it's easier, instead of me having to say 1 over cos or sine over cos or tan, I mean 1 over cos, 1 over sine, or 1 over tan, because you will at some point have to simplify it, and it will take you to there. So that means with you knowing that you just swap, it saves you time to go through this process. That knowledge is very, very much important because it takes that shortcut. Okay, so maybe let's try to see if we can do some examples. Let's see, I'm just curious to know. Okay, so consider the following. This is an example that I'm having there. Let's see what's going on there. So I can see we have that. It must have this, so that is a right angle triangle. We have small letter k, capital letter K, capital letter N, capital letter M. So it will be small letter n, small letter m that side. So now they are saying sine of angle n, it will be equal to small n over small k. When they say sine n, that means the reference angle is that one. So sine is opposite over hypotenuse. Definitely n in this case is the opposite, and then k, it is the hypotenuse. And in terms of the reciprocal, it means the cosec of that angle n will therefore be equals to, you just swap. That's all that you do. You don't have to think much, you just swap. And then when it comes to, let's say again, if they say cos of an n, it will definitely be, let's see, when it comes to cos adjacent, it will be small m over the hypotenuse, definitely k. So that means in terms of sec of that angle n, you don't have to think much, you just swap. That's all that you do. The nice thing about the reciprocals. So again, when it comes to what, tan, when it comes to tan of that same angle, tan should be opposite over adjacent. So that means we'll have n over m. So that means in terms of chord of that same angle will be, don't need to think too much, you just swap. That's all that you do. So that means for some reason, if you are given, let's say, cos, and then they say tan, and then they say sine, and here they can also mix and say cosec, maybe they say sec, and then they say cot. And then the question says, which one is the reciprocal of which? You always go to letter number 3. Letter number 3 is S. S for sine. So that means this is the cousin of that one. 1, 2, 3. Letter number 3 is what? Is C. So that means this is the cousin of that one. 1, 2, 3. Letter number 3 being T. T is the cousin of tan. That's how you easily work it out. Many get confused because of not knowing how to match them. But trust me when I say what I've just explained to you, very, very much important, because it will make your life very much easier. So now, let's see. Let us say here I'm having an example where on that example they can say evaluate the following without using a calculator. Number one, they can give you something like, let's say, cosec of 45 degrees. So you see now, the reason why they say don't use a calculator is because the angle that you are given is a special angle. Very much important that you always remember that when you are dealing with 45, 30 and 60, those are special angles. That means you need to simplify this thing, because it is not an equation but it is an expression, since it does not have an equal sign. So very much important, you will need to remember how the triangle is for that one of 45 degrees. It's 1, it's square root of 2. You just need to remember that one. Very, very much important there. Okay, so now let's see what's going to happen now. So that means in this case you will just need to remember that this is the reciprocal of sine, and we do know very well that sine is opposite over hypotenuse. So that means cosec for this one, it should be hypotenuse over opposite. So this is how you would therefore work it out, and then you look at that angle of 45, or that special triangle for 45, and say which side will be what is it, opposite, and which side will be hypotenuse. Let's see, hypotenuse is definitely that one, yes. And then let's see, opposite is definitely 1, yes. Okay, let me just quickly confirm something. Let's see. I don't know why, but I'm just suspecting something there. Okay, I just wanted to verify that I've got those triangles drawn correctly. Yes, it is drawn correctly. So that means our hypotenuse should be square root of 2 over opposite being 1, and this is supposed to be square root of 2. Yes, as an answer to that. Okay, then it's fine. So now we need to jump onto maybe question number 2. Then question number 2, there we are having seg 30 degrees that you multiply it by tan of 60 degrees. So again, we will say for a sec, it is the cousin of cos, which is adjacent over hypotenuse. So that means here is going to be hypotenuse over adjacent. That you will need to multiply it by what you already know for tan, which is opposite over adjacent. But be careful in terms of the special angles. So that means you will need to go to that special angle of 30. So for 30, so very much important that you know these diagrams by heart, because otherwise if not, you're going to be in a big trouble. So the hypotenuse for that special angle of 30 is definitely 2 over adjacent is square root of 3 that you will need to multiply it by. Opposite is 1, adjacent again it is okay, I'm running out of space there, square root of 3, of which, if you remember, we said this will multiply that will multiply. So you have 2 times 1, which is 2 over this ones, if you remember, we said you will just have 1 square root, then you have 3 multiplying the 3, which becomes 9. So it's like you have 2 over square root of 9, of which square root of 9, definitely that is 3. So the final answer ends up being 2 over 3. Very much important on that one. Maybe let's see. Okay, I might need to insert a blank page there, just so that I've got enough space to write on. Okay, then it's fine. Let's look at another example. Let's see what's happening here. Calculate the following, and they say rounded off to 2 decimal places. Okay, this is example B. We are done with example A. So for this example, you are given chord 26 degrees. What did I say? So for this one, where the angle is not that of a special angle, this is where now you can write it as 1 over tan 26 degrees. And then from there you punch it on your calculator. So you will say 1 over tan 26 degrees. So it gives you 2, they said rounded off to 2 decimal places, then it becomes 0, 5. Yes, this should be the end of it. It's not an angle, but you just punched that expression. So that's how you would work it out in case if it is not a special angle, where they say round off to whatever. Another example, let's say you have sec 36 degrees, which is being added to chord, let's say 63 degrees. So again, sec letter number 3 for cos. So that means it is the same as 1 over cos 36 degrees. That you plus it with letter number 3 tan. So that means this is the same as 1 over tan 63 degrees. Then what I'm thinking is that you can now just punch it on your calculator. Yes. Just hold on. I want to verify if I have copied it correctly. Okay, then it's fine. So that means you will have 1 over cos 36 on the side that you need to plus it by 1 over tan 63 degrees, and then rounding off to 2, it gives that. Yes, I just punched 1 over cos 36 plus 1 over tan 63 degrees. Yes, because there is cot, there is sec, then for cos. Yes, this is exactly how you would work it out, honorable member. Let me just quickly check if I've got some more examples. I think I do have some more. Okay, so now let's see, what else are we having there? Okay, those examples I've just done. Yes, I think I've just done those other examples. Okay, let's look at this one. It is example 17, where they say, without using a calculator, solve the equation. Okay, now they want you to solve the equation, and the equation must have an equal sign. So we are having cosec of an angle, which in this case is equals to square root of 2. And then they say that if this theta is a acute angle. So this statement, again, it simply tells you that that angle theta, it's an angle which is between 0 and 90 degrees, because that is an acute angle. But you don't need to worry that much. As long as you can work it out correctly, you should be fine. How are we therefore going to deal with it without using a calculator? Because that is the most important thing, where they say do not use a calculator. What I know for sure is that S stands for sine. What if I say this thing is actually the same as 1 over sine of an angle being equals to square root of 2. Yes, maybe let me just leave it at that. I'm just trying to rewrite it such that on the left I want to remain with sine. So if I want to remain with sine, that means I've got fraction on the left. I will also force this one to be a fraction, and then I will cross multiply, which means I will end up having this multiplying with that, this multiplying with that. So I have square root of 2 multiplying sine of an angle, which should be equals to 1 times 1, which is 1. Then if I want to remove this, I will have to divide by that on both sides so that it cancels. Then I'm having sine of an angle, which will be equals to 1 over 2. So this ratio, for the fact that they said without using a calculator, I must, in my mind, think of those special angles, because those are the ones where no calculator is required. If you remember, we have the one for 30 degrees, where we have square root of 3 here, we have 1, we have 2, and then another one for 45. So 45 can be there, where we have 1, 1, and then square root of 2. Let me do another one for 60. So the moment they say without using a calculator, first thing that comes to my mind is by consulting with the special angles, whereby on what I'm working on, you see this square root of 2, it actually takes me to the special angle that has square root of 2, which is this one of 45. So that's where I will actually go. And what I know is that definitely sine, if you remember, is the same as opposite over hypotenuse. So that means 1 if it's my opposite, square root of 2 if it's my hypotenuse. Let's see if it suits. Yes, 1 is the opposite, and then yes, square root of that is the hypotenuse. So that means this angle, it is 45. So it's more like the angle could either be 30, 45, or 60. So you need to rewrite whatever problem that you are given nicely in a form of cos, tan, or sine, so that it will be easier for you to match it with one of those. In conclusion, we can therefore say actually our theta is 45 degrees. That's how you can work it out. Not that much easy. You might need to do it over and over again until it makes perfect sense. So just try to redo this same one until it makes a perfect sense. And once that is the case, then trust me when I say, if they say work out something without using a calculator, and they've just given you a hint where they say theta is an acute angle. So the moment they say without using a calculator, always remember your special angles. And the best way you can do is to try rewrite this thing in a form of sine, cos, or tan. Then from there you will compare to say between this and that, which one will suit the ratio that I'm having as my final answer, which is this one. So if, let's say, for example, you had to work it out and you end up having just sine of an angle, let's say is the same as square root of 2 as you work it out. Just remember that you can force it to be a ratio. The only way to force it is to say divided by 1, because when you divide it by 1, it doesn't change anything. Then you will know what that is. Then you check from these 3, and then you check the one that has this and that has that, and then if it suits, then you will know that the angle is either 30, 45, or 60. That's how it works. So just remember that in case if you get stuck, you're expecting a ratio but it's not a ratio, you can force it by dividing it by 1. So what if now they give you an equation, and from that equation they now want you to round off? This one, it should be nicer because when you use a calculator, it's less complicated as compared to having to refer to those special angles. So now they say solve this equation and round off to 2 decimal places, again if theta is an acute angle. So that means you are expecting an answer which is between 0 and 90 degrees. You can do it in many ways. One of the ways, you can still say sec, it is the reciprocal of cos. So you can still say 1 over cos of an angle is the same as that 1,5. Then what you do, you force it to be a fraction, since on the left you have a fraction. The reason why you force it is so that you can cross multiply. That multiplying that will cross multiply with that. So you have 1,5 cos of an angle equals to 1 times 1, which is 1. Then from there, you will divide both sides by that so that it cancels completely. Then you remain with cos of an angle being equals to that 1 over that. Then you can just say angle is equals to that second function of that, or the inverse of that, whichever way you call it. Then you punch it on your calculator. Let's see, I will say shift cos, and then it's 1 over 1,5. You close that, you say it's equals to, it gives you 48,19 degrees because it is an angle. One of the ways in which you can work it out. Another way is for you to realize that for you to realize that if you have sec of an angle being equals to 1,5, what is 1,5 as a fraction? Let's see, it is actually 3 over 2. And then since sec is the reciprocal of cos, then if you change this to becoming cos of an angle, that means also this one you change it by just swapping. You see now, then you will just say angle should be equals to that, being that 2 over 3. Then you punch it. Let's see if it'll give us the same answer. Second function of, then it becomes 2 over 3 equals to, yes, it gives us a 48,19 degrees because it is an angle. So the reason why I had to teach you how to deal with the fractions is because I knew that at some point you're going to need that knowledge. So if you are not yet confident with the fractions, you need to go back to that introductory session regarding the fractions. Try to work it out, and then once you've done that, you will therefore work it out, master it, and come back to these problems. Because it's easy for you to know based on what I've explained. You say, the reciprocal of this is this, the reciprocal of this is this, the reciprocal of this is this. What may be challenging is to solve dealing with the fractions. So someone saying, I have a problem with this topic, the problem is not necessarily the topic itself, but it's the calculations where fractions are involved. So that's why you need to master calculations related to the fractions. Trust me when I say it is not that much complicated. You need to redo it over and over and over and over and over and over again. Do not just rush to doing an exercise, but try to watch this lesson as many times as you can. You can watch it for the first time, go attempt the activities. If you come across a problem which is challenging, go back to this recording, rewatch that part, and then attempt that. See how far you can go. And then if you get lower marks, you revisit it again until you master it, because there are more problems which are meant to be complicated than this, even though they are not necessarily complicated. If you can master how to deal with the fractions, I'm telling you, you are going very far. So I think for now I will just leave it here with the hope that you did understand everything. So I think for now I will just leave it here and say until we meet again.